Good day everyone, we are the Group 4 and presenting our topics, the kinematics of fluid flows. So in this topic, we need to know what is the real and ideal fluid and the classification of flow types. So before I start discussing our topic, let me define first what is fluid. So what is fluid? Fluid is a substance that deforms continuously when subjected to shear force. This continued deformation of a substance is called fluidity or fluid flow. The fluid is generally in the form of either only on a liquid or gas form available. So, kinematics of fluid flows. Kinematics of fluid flow deals with the motion of fluid particles without considering the agency producing the motion. This deals with the geometry of motion of fluid particles. This also deals with the velocity and acceleration of fluid particles in motion. The motion of a fluid can be analyzed on the same principles as those applied in the motion of a solid. Here are the two types of fluids, the ideal fluids and real fluids. Basically, madaming types ang fluids, pero ito lang yung binigay na topic. So, ito lang yung i-discuss namin. Ideal fluids. So, known as the perfect fluid. The fluid which are without viscosity, surface tension, shearing force, and compressibility. Ideal fluids are all imaginary fluids and do not exist in nature with such properties. However, a few fluids such as air and water have exceedingly low viscosity, surface tension, and great resistance to compression are treated as ideal fluids for all practical purposes as their assumption are helpful in simplifying the mathematical analysis. So, in ideal fluid, always incompressible, so it means constant density. And second thing that you should know is that ideal fluid is always going to have laminar, means steady flow. So, later on, madidiscuss kung ano ang laminar flow. So, example, if you look at water going to a pipe, let's say na see-through yung pipe, you would see that there's a constant stream of water and that looks neat and clean. And it always non-viscous flow. In other words, no friction. Yung flow ng tubig is smoothly lang at walang friction. So next is the real fluid or actual fluids. The fluid which have viscosity, surface tension, shearing force, and compressibility. All the fluids in actual practice are real fluids, and they offer a certain amount of resistance during fluid motion. So, sa real fluid, it could be compressible, could have turbulent flow, at saka may viscosity flow. Kapag sinabing viscosity flow, thickness of the fluid. For example, di ba, yung cup ng honey, then tinapon mo siya pa ganito. And then, yung flow ng honey is mabagal lang dahil yun sa viscosity. So, always remember, yung ideal fluid is incompressible, while real fluid is compressible. And ideal fluid is non-viscous flow, while real fluid has viscosity. And mostly yung mga problem na ma-encounter natin is ideal fluid, unless na sinabing real or viscosity. And in most real fluid problem naman, you will have viscosity pero wala siyang turbulence or compression of the fluid. And the next topic will be the classification of flow types.
Classification of flow types: laminar and turbulent. The highly ordered fluid motion characterized by smooth layer of fluid. The flow high viscosity fluid such as oil at low velocities is typically laminar. The highly disordered fluid types that typically occurs at high velocities and is characterized by velocity fluctuation. The flow of low viscosity fluids such as air at high velocity is typically turbulent. Reynolds classified the flow types according to the motion of fluids. Laminar flow. Every fluid molecule follow a straight path that was parallel to the boundaries of the tube. transitional flow. Every fluid molecule followed wavy but parallel path that was not parallel to the boundaries of the tube. Turbulent flow. Every fluid molecule followed every complex path that led to a mixing of the dye. Laminar flow or streamline flow in pipes occurs when a fluid follows in a parallel layer with no disruption between the layers. At low velocities, the fluid tends to flow without lateral mixing and the adjacent layer slide past one another like playing cards. Laminar flow becomes turbulent with an increase in distance from the leading edge because the effect of the fluid viscosity is progressive. The middle layer is then affect the viscosity force from the relative difference of the velocities of the two layers, inner and middle. Next is uniform and steady flow.
Uniform and steady flow. Steady flow. Steady flow do not change with position in the stream or with time. Example, flow of water in a pipe of constant diameter at constant velocity. Many devices such as turbines, compressors, boilers, condensers, and heat exchangers operate for long periods of time under the same conditions, and they are classified as steady flow devices. Steady non-uniform flow. Steady non-uniform flow change from point to point in the stream but do not change with time. Example, flow in a tapering pipe with constant velocity at the inlet velocity will change as you move along the length of the pipe toward the exit. Unsteady non-uniform flow. Unsteady non-uniform flow may change from point to point and with time at every point. Example, waves in a channel. Unsteady uniform flow. At a given instant in time, the conditions at every point are the same but will change with time. Example, a pipe of constant diameter connected to a pump pumping at a constant rate which is then switched off.
Incompressible flow and compressible flow. When the density of flow varies with pressure, it is termed as compressible flow. The cylinder is sealed so that the gas cannot enter or escape. The fluid volume changes as the piston moves. However, the mass of the system does not change because the gas is not allowed to enter or leave the cylinder. Therefore, the fluid density must change because of the change in volume. The examples of the compressible flows includes aerodynamic applications such as flow over a wing or aircraft nacelle, as well as industrial applications such as flow through high-performance valves. Incompressible flow. When the density of flow does not vary with pressure, it is termed as incompressible flow. When compression and expansion do not significantly affect the fluid density, consider a liquid in a cylinder. If the cylinder is sealed, the piston will stop moving once it contacts the liquid. As the piston retracts, an empty space is created above the liquid surface. The amount of space or the volume liquid occupies does not change. The example of the incompressible fluid flow is the stream of water flowing at high speed from a garden hose pipe, which tends to spread like a fountain when held vertically up, but tends to narrow down when held vertically down. The reason being volume flow rate of fluid remains constant.
So the topic I will discuss is 1, 2, and 3-dimensional flow. In generally, all fluids flow 3-dimensionally with pressures and velocities and other flow properties varying in all directions. In many cases, the greatest changes only occur in 2 directions or even only in 1. In these cases, changes in the other direction can be effectively ignored, making analysis much more simple. Meaning that one-dimensional motion describes objects moving in straight lines. Speed is a scalar measure of how quickly an object is moving along this line. Velocity is speed with a direction, making it a vector. If an object's velocity changes with time, the object is said to be accelerating. When restricted to one dimension, there are only two possible directions for the velocity and accelerations vectors to point in. Just like, for example, a car moving on a straight road. So, in analyzing the motion of objects, there are four basic parameters to keep track of. These are time, displacement, velocity, and acceleration.
My name is Jake Inwariso and I'll be discussing about 2 and 3 dimensional fluid flow. 2-dimensional flow, if it can be assumed that the flow parameters differ in this direction in the direction of flow and in one direction in the right angles. In this type of flow, the streamlines are curved lines on one plane and are same on every parallel plane. So in fluid motion can be said to be a 2-dimensional flow when the flow velocity at every point is parallel to a fixed plane. Like for example is flow over a car. Antenna is approximately 2-dimensional except near the top and bottom of antenna. Yun nga, parang masasabi ko na sa ganitong flow ang mga streamline ay nagiging curve or parang nag-iibang direction pero isa lang yung punto niya or point. Parang doon pa din siya napunta kung saan nakapoint or dapat na nakadirect. And I proceed to 3-dimensional fluid flow. In the 3-dimensional fluid flow, the hydrodynamic parameters are function of 3 space coordinates and time. This means that the flow parameters like velocity, pressure, and so on vary in all the 3 coordinate direction. The motion of fluid elements in space simultaneously has 3 distinct characteristics: translation, rate of deformation, rotation.
Rotational flow. It is a type of flow in which fluid particles also rotate on their own axis while flowing along the flow lines. Irrotational flow. It is a type of flow in which fluid particles do not rotate about their own axis when they flow along the flow lines. Overall view. The angular momentum of the fluid's elements is analyzed to classify any flows as rotational or irrotational flow. If the angle within the two intersecting lines of the boundary of the fluid elements turns while moving in the flow, then the flow is a rotational flow. But if the fluid's elements rotate as a whole and there is no change in angles within the boundary lines, the flow cannot be rotational flow. So it is a irrotational flow. To classify any flow as a rotational or irrotational flow, the angular motion of the fluid's elements is analyzed. If the angle between the two intersecting lines of the boundary, if the fluid elements changes while moving in the flow, then the flow is a rotational flow. But if the fluid elements rotate as a whole and there is no changes in the angles between the boundary lines, then the flow cannot be rotational flow. So it is irrotational flow. Example of rotational flow. Water flows down a drain in a counterclockwise direction in the northern hemisphere and in a clockwise direction in the southern hemisphere. That is because of rotation of the individual water molecules combined with the acceleration due to gravity. An example of irrotational flow would be flow of water over dam, in which the water flow is straight down and rotation doesn't have an effect.